Hello, algebra students. Welcome back after Thanksgiving. Today should really be your first synchronous day of class, but in case you wanted to re-watch any parts of our quiz review, here's the video that you can follow through. So what I did here is I just took the problems right from the quiz review worksheet that you have. It might not be formatted exactly the same way, like on your worksheet, these problems are all right next to each other, but here we've got all three problems that are in the section deciding if relations are functions or not. So remember, in these different relations, the things that we have to worry about in a table like this, I worry about the x's. I do not care about the y's. I know that some people see these two twos and say, oh, it's not a function, but that doesn't matter. I look at my x's, there's no repeating in the x's. That means that it is a function. And the reason is that each input, I won't be able to write small enough for this line, has one output. And again, really what we were worried about is that the x's can't repeat. And basically in a list of ordered pairs, it's the same deal. I'm worried about the x's repeating. It's not as obvious in a list of ordered pairs versus a table, but if I look at my x's, I've got a 5, 3, 1, 0, 1. Oh, right here. I've got an input of 1 that gives me an output of 16, and I've got an input of 1 that gives me an output of 6. So this is no, because one of the inputs has more than one output, or not each input does not have one output. Or you could have said one input has two outputs, something like that. In a mapping, it's again the same kind of information that we're caring about here, but I can't repeat any x's. In a mapping, we see repetition with the arrows. The 2 right here for an input has 2 different outputs, so that's a no. And again, it's the same as number 2, so you could say one input has more than one output. I'm going to word this one differently and say one input has 2 outputs. But again, the important thing is that it doesn't have just one. That's what we need, is for just one input, one output. Okay, the next problem is asking about domain and range. It's also asking about discrete and continuous. We mentioned this in class. This will not be asked on the quiz, but when we talk about discrete versus continuous, we're just going to do that first before we talk about the domain and range. Continuous is a graph where it's connected. It could be straight lines, it could be curves, it could be whatever. Anything that's connected makes it continuous because these are all individual points. They are discrete. Remember, the domain, that's really the x numbers. The range is the y numbers. So if I take each ordered pair one at a time, I like to just kind of go one ordered pair at a time. This x, or this ordered pair right here, that's at 0, -5. The x part of it is 0. The y part of it is -5. The next ordered pair right here, I should have picked a different color, I think, is at 1, -3. So the x is the 1, the y is the -3. For this third ordered pair right there, that's at 2, -1. So the x is 2, the y is -1. The fourth ordered pair is at 3, 1. So the domain is 3, the range is 1. And then for this last point right here, the x is 4, the y is -3. Now, I already have a -3 right here. I don't need to rewrite it. You could. It's not going to be wrong. But if we're trying to make a list, we don't usually repeat numbers in that list. Same kind of question here. And again, this is discrete because we have separate points. So again, the domain is all the x's, the range is all the y's. Some people, instead of doing one ordered pair at a time, like to just list what all the x numbers are and what all the y numbers are. So I'm going to do this problem that way. It's not the way I typically do this. But for this point right here, the x number is -3. For this one, the x number is -1. For this point, the x number is 0. And then I've got, at this point, I have 1 for my x, and then I've got 3 for my x. For the range, the y's, now I'm looking up and down. So the bottom ones, these two are both for y's, those are at 0. So again, this ordered pair right here was at -1, 0. So I had my -1 right here, and that would be the 0 that goes with it. And I had a 3, 0, so that 3 right there also uses that one. These 2 points are both at the same y value of 2, and that would match up with the -3 and with the +1. And then this last point has a y value of 3. Personally, I think more people make mistakes doing it this way. If you wanted to just go one ordered pair at a time, write your x's in the domains, the y's in the range, that's what I prefer, but this is just another method for doing that if you want. Okay. Here we're looking at 3 problems, and again, these on your paper are right next to each other. I am trying to decide if these are linear or nonlinear, and then you also have to explain why they are what you say they are. So in number 6, these points, I know they're not connected, but they are in a straight line. So it doesn't matter that they're not connected. This is linear, and you can just say straight line. It's good enough. In a table, we are looking for a constant rate of change, a crock. So if I look at my x's, this increases by 3, and then it increases by 3 again. Sorry, that first 3 was kind of hard to read. In the y's, this is increasing by 3. This one increased by, 2. It does not have a constant rate of change. There's no crock. So this is nonlinear because it does not have a constant rate of change. You could even just write, not a crock, or not a constant rate of change. For number 8, in an equation, we are looking at, can you make this look like slope-intercept form? And I know this year we haven't really talked about slope-intercept form much yet, but slope-intercept form you used last year, it looks like this, y equals mx plus b. The big thing here is, do you have regular x's and regular y's, like not squared, not square roots, nothing weird like that that's going to mess it up, no variables in denominators? You can have fractions, but the variables can't be in the denominators. Can you make it look like this? And number 8 absolutely looks like slope-intercept form. So I know that it's got a minus instead of a plus, but hopefully you remember that that means that it could just be plus a negative. So this is linear because it's in slope-intercept form. Okay. For number 9, filling in this table of values, we are giving you x numbers. The rule that we're following on this is that I'm going to take whatever x number I have in my table and I'm going to add 2 to it. It's not hard, right? So if I would have -1 and then I would add 2. If I'm showing my work, it would look like this. Y equals -1 plus 2, which is +1. Hopefully you can just add 2 to each of these in your head. So 0 plus 2 is 2, 1 plus 2 is 3, 2 plus 2 is 4. Because the x's are in a pattern, the y's will be in a pattern. If the x's weren't in a pattern, you can't depend on any kind of a pattern there. Now we have to graph this. -1, whoops, I just graphed that wrong. We need -1, +1, 0, 2, 1, 3, and 2, 4. And then you should do your best to get a straight line there, hopefully with a straight edge. Here's another table. It's got a fraction. We're not afraid of fractions. But again, showing your work on this, it would look like this. Y equals -1/2 times -2 in this case. Well, they're the same signs, which is going to be positive, and half of 2 is 1. You guys should know by now, 0 is my favorite because Anything times 0 is just 0. I don't have to do any math. To do the positive 2, honestly, I would reuse my work from this first one. I would just change that to a positive 2. Now, I know that half of 2 is still 1, but now it's a negative 1/2 times 2, so it's going to be a negative 1. And then negative 1/2 times 4. Well, half of 4 is 2. Negative 1/2 of 4 is going to be negative 2. Again, you should see a pattern in the y's. So negative 2, 1, 0, 0, 2, negative 1, and 4, negative 2. All right, these last couple of problems are kind of a preview, actually. They are not going to be on the quiz, promise, but it's stuff that I'm hoping you kind of remember from last year. We want to find the slope of the line between 1, 4, and negative 6, 2 is right here. I'm not even going to draw in the line right now. What I want to do to remind you again, remember we count rise over run? We use M for slope, and we'll be reviewing all of this with you. But we go with rise over run. We want to know how much you go up and down and how much you go sideways. Maybe you even remember Mr. Slope Guy. This is a positive slope. It's going uphill as I go from left to right. I'm going to go up 1, 2, and then I go sideways 1, 2, 3, 4, 5, 6, 7. Okay, so that's telling me that my slope is going to be 2 over 7. It's going up 2 and sideways 7. And the last review problem, talking about x and y intercepts. I know this is not something you spent a lot of time on last year, but we will be talking about this more. X and y intercepts are where a line crosses the x-axis and crosses the y-axis. To be able to cross the x-axis, so here's my x-axis right here, that means I don't want to go up or down at all, which means that the y should be 0. So let's substitute that in. If the y is 0, does it make sense that saying 5 times 0 right there is going to be 0, and subtracting that 0 doesn't do anything? Really, this whole part of the equation just kind of goes away. So I'm looking at 2x equals 10. Well, x equals 5 then. So 1, 2, 3, 4, 5. Right there is that x intercept. To find the y-intercept, here's my y-axis. I don't want to move sideways at all, which means that my x number has to be 0. If the x number is 0, then I would have 2 times 0 right there would be 0. So I would really have 0 minus 5y. Here's the thing. That really just turns into negative 5y equals 10. Now, in your head, you should be able to look at that and say, okay, negative 5 times what gives me positive 10? That's going to be a negative 2. Right there's my point, and then I can draw my line. I know that those two were a really fast lesson/review on those topics. Don't worry about those two for tomorrow's quiz, okay? So your chapter 3 quiz review sheet should be done. Those are your regular practice problems. You can check it with the answer key in Schoology, but we just did it together and you've got all the right answers. Make sure you take the formative quiz in Schoology when you're all done, and let me know if you have any questions.